is an introduction to embedded system programming in C. And the main objective here is to just discover why we are using C programming for electrical engineering students. Okay, so what are our goals? Our goals are mostly to help students prepare them to program and develop embedded systems. So if you're wondering what an embedded system is, it's a computer system, but that you don't think of as a computer system because it's embedded, it's inside of some other digital system. So here are a couple examples. It could be an ATM, a printer, a copier, your security code system at your home. Your car has tons of embedded systems, your microwave, your laundry, there's so many examples. And so we need students to be able to develop programs to control that hardware. What's different about an embedded system, rather than just a general purpose system, is the ability to do that control of inputs and control of outputs. Okay, so in addition, another goal is to, let's see, my computer is frozen. Okay. So another goal is to teach C programming, okay? What we mean by that is that we want students to be able to develop the skills to be able to program in some language, and we've decided to teach that as C, as we'll discuss in a minute. And lastly, in addition to just learning a particular programming language, we want them to develop the skills to develop software. So how do you identify a problem? How do you develop the solution to a problem? And then how do you code it up and test it to see if it works? So C programming, why C? Well, here we see an example of a development breadboard that we'll use in our subsequent course that has not only the board that has an embedded system, a microcontroller, but it also has some of the input and outputs. So some of the inputs are a variable resistor on the left-hand side here, as well as some LEDs. So the students are going to need to know how to control that, and C, rather than Java or Python, is a good one to learn because it's has the ability where pointers, to support pointers, which pointers are really just memory addresses, and memory addresses allow you to be writing and reading to the hardware itself and controlling what's going on in hardware. So we are controlling those input and output devices. And once you pick up one language such as C, then it's relatively easy to pick up other languages like Java and Python and such things. Although some of those languages require object-oriented, which is beyond the scope of what we're trying to do in this course. Okay. So the flipped classroom model that we're trying to approach here, some of the things we brainstormed so far, what to do outside the classroom, is that we are going to use, there's many existing video lecture resources such as the Bucky videos on YouTube. We also are going to be adopting an interactive textbook where the students will be doing programming in C with Xylab. So that's going to have, as they're learning the content, they're going to be able to be doing quizzes and practicing, and there's already a textbook developed for that. And we're also going to be adding our own supplemental videos for tougher concepts such as debugging or test-driven development. Some of the more complex ideas, we'll introduce some of those through some videos. Inside the classroom, we're going to encourage the students to be doing some of these outside the classroom activities, videos, or readings by starting out the classes with individual followed by group quizzes. So this is like a team-based project learning approach, or team-based learning approach, where initially they're doing a quiz. We can grade that quiz with a zip grade, and then they're going to do the same quiz with their team of students, and they're going to use this immediate feedback assessment technique where it's like a scratcher, and so if the group decides that D is the best answer, they'll scratch that off. They see it's right, and they get full credit for that. But if they're trying the next problem, they thought A was the best answer, and then they find out they're wrong, they do B. B, then they get a reduced score. And so this is going to really encourage them to be competitive with each other and try to get the best possible score, but also really discuss the problems in a group and really understand the concepts much deeper. We're also going to do paired programming where the students will sit side by side. One of them will be programming, talking through their process of how they're doing the program. They're developing their skills, and as they are doing that, they're developing their critical thinking skills because they have to explain to their partner what they're doing, and at the same time the partner's listening and thinking about how their partner is approaching it, and then pointing out any mistakes that they might observe as the partner is going through and typing up the program. And another technique, and they'll take turns so that they both have the ability to do that. Another thing we've talked about is that we should do a group project in the class and make it an open-ended project where the students have the autonomy to select their own project, and that it will develop team skills and, again, project-based learning and team learning. So these are some of the ideas that we've thought about so far.